For my final presentation, I'll be presenting on copper with a focus on Michigan's copper industry. This presentation will cover the geology of copper, globally and specifically within Michigan, the extraction techniques for copper, covering a timeline of extraction in Michigan and the current techniques in use around the world, and the environmental impact of copper's extraction. Then we'll discuss modern and ancient uses for copper, and finally, economic and social implications. First, the geology of copper. It's obviously important to understand where copper comes from before we delve into anything else. So let's talk about the three types of copper deposit that exist. The first is porphyry deposits with igneous rocks. This makes up 45% of the world's copper deposits. As you can see on this figure to the right, copper deposits, porphyry copper deposits, are found all over the planet on almost every continent except Antarctica. These are formed when hydrothermal fluids leave metal ore behind. The second most common type of deposit is the strata-bound deposit. These are present in Zambia and Congo in the north-central United States, as well as other places in the world, which we'll see in a few minutes. They are formed when copper is held within a stratigraphic layer in sedimentary or volcanic rock, which means you could cut a cross-section of the area and you'd only see copper held in that one specific layer. And finally, sulfide deposits. These also include copper, nickel, lead, and zinc in the same place, and are found in eastern Canada and the eastern United States, as well as Australia, South Africa, the Philippines, and Cyprus. They have well-defined boundaries and are formed by volcanic activity in submarine zones, either in historic oceans or modern oceans. They form when the sulfur-rich hydrothermal fluids cool rapidly into mineral-rich deposits. And here is a very colorful map of the globe. What we're looking at here is color-coded by continent copper deposits. So in the lighter colors, we have porphyry deposits, and in the darker colors, we have sediment-hosted strata-bound deposits. You can see on figure A, the world's porphyry copper deposits, and on figure B, the sediment-hosted strata-bound deposits. And if you notice the yellow circles, the yellow arrows pointing to the circle on the top right of the screen, let's zoom in there and learn more about Michigan's copper deposits. This is the Mid-Continental Rift System, and this is where copper in Michigan comes from. Compared to other copper deposits, the Mid-Continental Rift System is one of the smaller deposits in North America. But in the 19th century, it packed the biggest punch in the country. And let's learn more about how it formed and what resulted from that. So the Mesoproterozoic Mid-Continent Rift System formed 1.1 billion years ago in the center of the North American continent. It was 1,200 miles long, stretching from Kansas up to Lake Superior. And it actually is the reason that Lake Superior was formed and exists today. The first stage of shifting was caused by a hotspot that weakened the continent, and lava came through, and it pulled apart, extending and stretching into a rift. And then a second phase happened where it was pushing and compressing and closed up. And it results in us being an intact continent today. Otherwise, there would be a deep ocean roughly parallel to the Mississippi River. But I'm sure Lewis and Clark would have appreciated the shorter journey to the ocean. In fact, this rift was caused by heat and lava weakening the area, as I said, and the entire area is rich in ore deposits and native copper as a result of those hydrothermal fluids. In the image here, you can see the copper occurrences along the Keweenaw Fault. The Keweenaw Fault is the portion of the Mid-Continental Rift that is rich in minerals and runs up the Keweenaw Peninsula in Michigan. You can see highlighted in blue the Keweenaw Fault, and highlighted in blue on the table on the side is abundant native copper occurrences. The Keweenaw Peninsula has an exceptionally high concentration of copper in a very small area. Particularly native copper is found here. Native copper being copper that is found not in ore form, but just as copper, like the image on the bottom right of the slide. Copper is only one of a few metals that can be found in native form. And this figure illustrates where copper is commonly found in the Keweenaw Fault and the type of copper. As we can see by Houghton and Calumet, we see native copper. And down by Copperwood and White Pine Mine, which is in the Porcupine Mountain region, we see the sediment-hosted copper deposits, and they'll be mining ore more commonly. So these two maps also just emphasize that the region of the Mid-Continental Rift, especially up around the UP and Lake Superior, is exceptionally rich in minerals. It shows just how much of the copper deposited by the Mid-Continent Rift system is in the UP itself. and emphasizes the sheer density for such a small area. It also shows the other minerals in the Lake Superior area, such as silver and lead and zinc and amethyst. So now that we know how copper is formed and where it actually forms, let's talk about how it's extracted from the earth. In Michigan, copper was first extracted between 5000 BCE and 1200 BCE. Indigenous people dug shallow mines and used stones to hammer the copper out of the stones it's held in. It was then melted over flame. These archaeological sites were found around the Isle Royale National Park and Lake Superior, and they were significantly large mining sites for the time. The archaeologists found traces of lead left over from smelting that indicate that they were mining copper. Indigenous people were hammering out native copper to use as tools 6,000 to 8,000 years ago in this same region that we now are talking about today. When we think about the environmental impact of copper mining, we can keep this in mind that the impact of the lead from smelting copper in 5000 to 1200 BCE is still felt today, and consider the global scale of mining now and how much that impact will still be held on our planet. So next, in 1845, the white men first discovered that the UP was rich in copper, which prompted a copper rush to the UP that was more profitable than the gold rush itself. And the initial extraction was done by hand by individuals. But chiseling large masses of native copper out of the earth was inefficient and not very productive. So then in 1856, industrialization occurred. Capital came in and established mining companies, which shifted away from the tricky native copper and toward the amygdaloid and conglomerate lodes. They dug into the earth in tunnels to remove the ore and send it to stamp mills to be processed. This mining was efficient and profitable, despite the fact that they were mining the less pure copper, and it led to copper production in the Keweenaw region peaking in 1870, where it was providing half of the United States copper. And now in the modern day, mines such as the Eagle Mine continue to extract ore underground. On a global scale, copper is extracted using different methods. And this does vary globally by location and size of the mine, but it is mainly all focused on the removal of ore from the earth and processing that. Open pit mining is used commonly all around the world, including in the US. This image on the left is of the Kennecott Copper Mine in Utah, which is an open pit mine in the mountains of Utah. Open pit mining removes the ore from the earth, crushes it smaller, and then processes it to get the copper out. Or two types of copper ore are found in the earth. Oxide ore is found closer to the surface, and it is processed through hydrometallurgy, which is water-based processing. But sulfide ores found deeper in the earth need to be processed through pyrometallurgy, heat-based processing. Now that we know how you extract copper, let's look into the environmental impacts of mining, specifically with copper. Michigan's environment has suffered from the 100 years of mining that took place in it. The dumped waste from the copper boom has led to Torch Lake, seen here on this image, being designated an EPA Superfund site due to the dumping of waste and the sheer amount of it in and around the lake. This image shows areas where waste has been dumped in Michigan. And this waste is called stamp stands, and it is sand mining scraps from the ore processing that contain copper and other metallic particles in high concentration. And in one specific instance, it was dumped near a shoreline, and the wind and storms have been pushing it into the water, causing toxic copper levels to rise in the water, killing and smothering the fish in these fish spawning grounds of Lake Superior. The Upper Peninsula was also cleared of its old growth forest for the mining infrastructure. I have personal experience with damp sands, and which I didn't even realize until I was planning this presentation. I remember being in the Upper Peninsula, and most of the beaches are quartz sand, which is the natural sand of the region. But stamp sands are this dark gray-brown color because of their high metal content. This is the mining byproduct that is washed up the coast from, if you look at this map image here, from the third arrow on the left, has washed northeast up towards the entrance to the Keweenaw waterway and collected on the beach here. There's a really interesting chart designed by Michigan Technological University that you can track different kinds of stamp sands on the UP and see where they've come from. The environmental impact of copper mining globally is extremely high. Copper ore results in higher pollution than native copper because of the waste processing that the ore produces. Additionally, smelting copper releases sulfur and lead into the atmosphere. We can see a case study here of artisanal copper mining in the Amazon. These mines result in waste that enters the environment. It contains arsenic, cadmium, cobalt, chromium, manganese, nickel, lead, and zinc. Artisanal copper mining is relatively new to the Amazon region compared to gold mining, but it has less oversight because of that. Artisanal copper mining is less common than industrial copper mining, but 70% of Brazil's mines are artisanal mines, and metallic ores from artisanal mines that are not properly processed release potentially toxic elements, also known as PTEs, into the wastewater, which then enters water supplies, soil, and plants. These cause risks to human health through ingestion, inhalation, and dermal contact. This isn't localized to the Amazon, though. Any type of waste that isn't properly controlled can cause this harm to health and the environment. And finally, copper mining causes significant environmental damage. The mines we talked about in Michigan are all underground mines, mining veins of copper in the ground. But the most common type of mine, which we just learned, is the open pit mine. These mines can cause permanent damage to the environment and ecosystem of an area. Both these images are open pit mines. The image of the left in Utah, we can see permanent destruction to the mountainous terrain and ecosystem, which disrupts the water paths and destroys the area. The right is a photo of a mine in the forested region of Panama, indicating the scale of deforestation that takes place and the loss for the environment. Now that we know how copper is formed, how we extract it, and the impact of extracting it, let's talk about why we even go through all that in the first place. How do we use copper? Well, historically, copper was one of the very first metals to be used. Its usage dates back to the Neolithic area, and it is one of the metals that we've been using for the longest time. This image here is of tools found in what is now Wisconsin, but they date back to 4000 to 1200 BCE. Coincidentally, these would also have been made with copper from the mid-continental rift. Copper was also used to make vessels, tools, jewelry, and coins throughout ancient times. Copper is now used for even more things in the modern world, including everything that has been mentioned before. Copper usage is projected to increase due to its use in the electrical industry. That's its largest market now today. Copper is still used in coins as an alloy, as well as in musical instruments and pipes and kitchen tools and other hospital essential items due to its antimicrobial properties, and in architectural or sculptural features for its aesthetic properties. Here's a handy graphic from copper.org that shows just how essential copper is to our way of life. The industries that use copper include infrastructure, clean energy, transportation, defense, and healthcare, among others. Copper is necessary to continue the production of these industries. Especially pressing for this class is the idea of clean energy and the demand to switch to it. Copper.org also helps us visualize how copper's use will grow alongside our clean energy growth and how we'll need to meet this demand. So now that we've seen how essential copper is as a resource, let's talk about the economics behind it. A general consensus is that copper usage indicates economic health due to its use in a variety of sectors and its global presence. Copper prices are high, the economy is strong. Copper prices are low, that's not such good health. It's pretty intuitive stuff. Taking Chile as a case study, we can see that copper mining contributes to massive economic growth as their industry has grown between 1990 and 2016. This comes through the establishment of industrial large-scale mines, where they found that poverty was reduced by 30%. The top copper-producing nations of the world are at number 5, the USA, at number 4, the DRC, at number 3, China, at number 2, Peru, and at number 1, Chile. And Chile as a case study indicates just how important harnessing copper as an industry is for your country's economic health. Michigan's copper economy is not the same as it once was. Copper production in the Keweenaw Peninsula peaked in 1887 after the mines had been industrialized for a few years, but already by 1870, Michigan has been producing half of the USA's copper on its own. By the 1900s, the industry took a downturn, which resulted in economic power decreasing. Now the UP's economy primarily relies on tourism, education from Michigan Tech, Northern Michigan, and Lake Superior State, and logging. Copper tourism does live on and brings income to the region, but it seems nearly impossible for the region to reach its former glory. Mines do still operate in the Keweenaw Peninsula. We talked earlier about the Eagle Mine, which was established in 2014 and is projected to run through 2029, but plans have stalled for more mines, which would bring back economic power to the region. Now, Presently in the United States, Arizona, Utah, and New Mexico are the top 3 copper producers in the United States. Now the social implications of copper. Returning back to Michigan specifically, the social impact of copper mining on the UP is extreme. The UP as we know it today would not exist without copper. Copper's importance was known by the first people to ever mine it back in 5000 BCE, and since then, until 1836, the region was inhabited by the Anishinaabe people. In 1836, the Anishinaabe ceded the territory to the colonizers for a payment, and the white man then discovered copper there, and the copper rush began not long after. The mining rush brought a massive population boom to the Keweenaw. Finnish and Cornish people made up the majority of the immigrants coming to reap the benefits of copper, followed by English, Italians, Croatians, and Germans. The towns of Calumet, Houghton, Hancock, and Ontonagon existed only to serve the copper miners. They did not exist before copper industry found the UP. Calumet in particular became a center of culture for the region, and at one time held the highest population in all of Michigan. The building on the left here is the Calumet Theater, which is a really historic building for its cultural impact, its architecture, and just the whole history surrounding it. In Houghton, Michigan, the Michigan Technological University was founded to train mining engineers in 1885. It's safe to say that copper created the culture of the UP as we know it today. But in the early 1900s, the mining industry was already on the decline after a series of incidents and a big strike in 1913, as well as global copper production increasing. People began to move south to Detroit, searching for success in the burgeoning auto industry, an industry with a potentially more impactful future than copper seemed to have in the UP. The population and economic decrease continued until copper mining fizzled out in the late 1960s and only a few mines remain. The mining industry never returned in full force to the Keweenaw Peninsula. However, its social effects last, as the oh-so-popular Northern Michigan pasty was brought by Cornish miners, and Finnish flags still populate homes and yards in the area, despite that being generations and generations ago. A global social impact, copper mining has created industry in many areas of the globe. If you recall the top 5 copper-producing countries, the USA, the DRC, China, Peru, and Chile, we see that those are in various areas of the globe and all different continents almost. But from copper mining, conflict often results. Specifically, industrial copper mine expansion has resulted in forced evictions of citizens of the Democratic Republic of the Congo. Artisanal copper mines are also a potential breeding ground for conflict, and copper mining in general shares the usual outcomes and impacts of minings, where there are pros and cons. Industry and economic health can be brought to a region, but it also opens up doors for people to be taken advantage of and the environment and towns to be harmed. Copper is a rising need. As we have seen, copper is in high demand for green energy creation, and demand is projected to double by 2035. According to CNBC, the world is behind on production to meet that bill. People largely agree that there is more than enough copper around our planet to fulfill the need, but acquiring the copper and doing so in a sustainable way is the critical need. Copper is also a social issue. Even in the UP, where copper was the reason for existence for 100 years, the mining process itself is now controversial. Copperwood Mines seeks a $50 million government grant, but the process has been stalled as locals and organizations are presently pushing back. And this has all been happening in spring of 2024. Environmental and local economic concerns dominate the argument. People concerned about the placement of the copper mine near the Porcupine Forest area, which is a significant tourism and hiking and wilderness area, and economic concerns about the amount of money spent for the mine, which would only provide about 400 jobs, and how the money could be put by the government back into the community itself directly. Communities, plural. I will close with this question before I share some personal photos. Copper is an essential metal for a clean future, but as it's one that must be mined, which results in environmental and social consequences, how can we move forward with this dichotomy? In what ways can we promote clean mining and clean usage of metal? And here are some personal photos from my family's trip in 2021 to the UP. Up on the top left, we have a picture of a mine outside Houghton. Then there's me outside the Mineral Museum at Michigan Tech. I thought that sign was really funny, and it's fun because now I get to use it in this presentation. Big, huge chunk of native copper. This was like 4 feet tall, like 3 or 4 feet. More native copper on display at the museum. It was so beautiful to look at and see all these different natural formations that it takes. And then finally, a picture in Copper Harbor taken from a bluff overlooking north up the Keweenaw Peninsula. Copper Harbor, of course, once a mining town. Now it serves mostly for nature adventures. We went there to mountain bike, and boats depart to Isle Royal National Park from there. So, yeah, thank you for listening to my presentation on copper.